Chapter 13 Lecture on Project Planning and Scheduling. There is many videos on ReggieNet that has some sort of a heading of network. So that's going to be your go-to for most of this chapter. So just want to point that out. And remember, exam 3, not 2, 3B is based largely on this chapter, especially doing network diagrams. I do want to point out some project objectives and trade-offs for budget versus schedule. Sometimes if you have a very tight budget, you don't have much to spare, you may have scheduling problems because any sort of hiccup in the process will likely put you behind because you don't have necessarily the extra money to have people work overtime or do whatever needs to be done to expedite it, try to, ship in via air parts from your supplier, whatever it happens to be. So sometimes there's an issue with that. Budget versus performance. If you're on a tight budget, then you may have performance issues because you may not be able to fully investigate all of the best practices and best equipment and best parts for trying to obtain optimal performance. Of course, on the flip side of that is if you have a big budget, sometimes your performance is enhanced because you have more time, you have more resources to try to figure out what's going to give you the best product performance. Same thing with budget versus schedule. If you have a bigger budget with some extra money built into it, then your schedule may be more likely met because you may be able to have people work overtime, ship stuff in more quickly, whatever the case may be. And of course, schedule versus performance. If you're on a tight schedule, performance may be impacted negatively because you may not prove out the product as much as you would if you had more time. Typical planning sequence, project planning sequence. And remember here, if you're looking for answers here, this is not a Control F1 because it's just an image. Again, watch out for the Control F here with the questions. The Gantt chart. One of the things that they indicate in the lecture material, the book, is that they say the Gantt chart is inadequate because it does not show the interdependencies and relationships between activities. So what they're saying is that you lease the site and then you start hiring the workers. Well, is this independent of this, or are they interdependent? It doesn't really show. However, with more of the new software, it can be programmed in what is dependent on what. So this constraint is really not much of one anymore regarding Gantt charts. I would say in your professional career, you will use Gantt charts a fair amount, just because if you're working on a project, you want to lay it out and people want to see that you have thought through every step and does it make sense. Okay, the Gantt chart versus the network method. Again, constant time networks, that's what exam 3B is all about. That's one where you work with yourself or with one person, and it's of your choosing. So I'm not going to spend much time on this because I've worked them out, multiple ones, in great detail. I will point out that sometimes you'll see that there's more than one path product flows from beginning to end, and it's the one that the critical path is the one that's the longest time to complete. And I'm gonna, what do I have us up here? No, I don't. Okay, let me go on to, like for example, I want to point this out, is you may say, we're going to do this operation, which is decide on the topic, and then over here you're collecting data, over here you're searching the internet, and over here you're writing the report. Well, if this takes 2 days to do, this one takes 3 days to do, and you really technically could not write your report. This is not a very good example, but technically you could not write your report until you had your internet search done. You're saying I need this information and I need this information, and so I cannot start writing a report till the thing that takes the longest is done. So that's why the critical path ends up being this one, because you see at the time 1 plus 3 is 4 plus 5 is 9. If I look at this other path, 1 plus 2 is 3 plus 5 is 8. This one takes 9, this one takes 8. This is the critical path just because there's no time to spare. If I were to goof off right here and say, I'm going to take an extra day, or I had to take an extra day, I still get done in 5 days. I still get done in 5 days. Because if I said 1 and I took an extra day, that's 3, that's 4. If I said that was 3, 4 plus 5 is 9, I still get done at the same time. However, if I goof around and spend an extra day here, watch what happens. 1 plus 4 is 5 plus 5 is 10. I just added a day to my process. Okay, here's various solutions. Again, you're going to see things on this all the time. I will point out is, what does calculating the LS and LF do for us? That's the late start and late finish. When you start working these things out, what you'll notice is that you do the LS and LF. I'm not going to talk about them now because, again, I talk about them exhaustively in other videos. Is that when you see these top numbers not match the bottom numbers, you know that this is not on the critical path. Whereas these two numbers and these two numbers match, these two numbers and these two numbers match, these two numbers and these two numbers match, that is your critical path. But we already determined that a few minutes ago. And why do we care about the critical path? As I said before, if there's any delays on this critical path, it changes when you finish. Even if this is added, even if you add a day to this, you're still going to finish after 6 days. Or if you have a day to this, you're going to finish after 6 days. So any extra time spent on the critical path is going to delay your completion. All right. The PERT. I have found that the PERT is relatively problematic. The reason I say it's problematic is you're supposed to give an optimistic time estimate, a likely time estimate, and a pessimistic time estimate. It's a bit tricky because they're estimates. And if you really expected it to be delayed, you may not know all the reasons why it's delayed. Or if something comes in sooner, well, then chances are you may not have known about it. So it's a little bit of a problem. It's kind of like throwing junk in, junk out in some cases, because if these numbers are not accurate, then your output numbers are not accurate. Okay. Exam A, there's ReadyNet videos on all these things. So exam B, etc. Moving along, critical path method. And one of the things that the critical path method assumes is the process can be reduced, which means process time can be reduced, which means I can, instead of taking like 5 days before, I can finish it in 4 days or 3 days. And so if more money is spent. So how might process times be reduced with more money? Let's just say I'm a little bit delayed, or my customer wants it a day or two sooner. I can just have my people work overtime, get it done. It costs me extra money, but I can get it done. So that's really what happens with this question. All right. And again, these are, I do want to point out, is that a lot of these things, example D, etc. Here's a solution for A. Here's a solution for B. Here's a solution for C. I think that's C. C. Here's a solution for D, and etc. So you have not only the problems to work out, you also have the solutions, and you also should have videos that explain this process as well. So that concludes this chapter, just one segment.